All right, today we're essentially in 15 now, and we're going to talk a little bit about sunlight and climate, things that you should already know so we can go over it pretty quickly. But we had talked about this to a certain extent before. We're just going to cover it a little bit more exclusively now. If this is my generic Earth, where was the biodiversity the greatest? Near the equator, as long as you're talking about living things on land, right? In the ocean, it's a whole different story, but on land, biodiversity is the greatest at the equator. Why was it the greatest at the equator?
Because it's
Consistently warm. And there's more direct sunlight, right, Ryan?
Yeah.
So that's definitely on the right track in both cases. But the equator is where you're going to see the most living things because it's consistently warm. There's lots of direct sunlight that's good for plants, right? And it's the combination of that direct sunlight and the curvature of the Earth to begin with that makes it consistently warm at the equator. You guys need to understand, if you didn't already, that the sun is really, really far away from us, right? And that essentially means that all of the light coming from the sun and actually striking the surface of our planet, all of that light is essentially traveling in parallel paths. If that light wasn't parallel, it wouldn't miss us altogether. There's no way that it could actually hit the Earth, right? So if you think about it a little bit, if I wanted to play catch with Enrique right now across the room, throw a baseball to him, right? I have to be pretty well on target to get it to him, right? Now imagine he is millions of miles away from me. I have to be even more accurate with that initial throw. Any little miss, any slight error one way or the other, I'm going to miss him by billions of miles by the time it gets there, right? So all the light traveling from the sun to the Earth is essentially in parallel paths, right? So here it's parallel to here is parallel to here, right? And if it wasn't, then it wouldn't have hit us to begin with. Does that make sense? So where is the sunlight hitting our Earth more directly? Up here at the pole or here in the middle? In the middle. So where's it going to be the warmest? There in the middle, right? So we have these boundaries that they talked about. Now these are different than the dotted line. The dotted line is just the equator, right? But this chunk in here is tropical. It's going to be warm year-round, right? Because it gets the most direct sunlight. That's why it has the most living things, the greatest biodiversity. That's my tropical region. In between those two tropics, right, it's Capricorn and Cancer, but I can never remember which one's which. Does anybody happen to know for sure? I don't know. But you have those tropics, and in between, the tropics are just measures of latitude, right? It's like 20 degrees north or 20 degrees south. But in between, that's your tropical region. It's warm consistently year-round, right? If you're in one of these two areas, it's not tropical, it's temperate. And that's where we are, right? What's special about our climate? What's temperate have that the other things don't? As seasons. So yeah, sometimes it's really warm here, right? In the middle of July, maybe in August, it's going to be dang hot, right? But in the winter, it's really cold. But it's seasonal. And that happens here, that happens here. And then you also have the extremes. It's supposed to be on my highlighter there. And that's your polar regions. And again, all of this is just based off is there direct sunlight or not? Because if the sunlight hits directly, if it's essentially perpendicular when it strikes the ground, that energy is better absorbed and it's just warmer there. Right? If it's a glancing blow, like up here at the polar ice caps, right, it doesn't really get absorbed very effectively because a lot of it just bounces directly off, right, and never really even gets to the surface. Right? And then we talk about the seasonal part of that too. Why is it warm here in the summer and not in the winter? Because of the tilt of the earth. Right? So we have this path that we take around the sun. Right? This is supposed to be flat and orbit that's in kind of elliptical in a shape, but for the most part it's pretty circular. Right? If you actually measure the distance between the earth and the sun, we're actually closer to the sun in the winter than we are in the summer. So it has nothing to do with how far away the earth is from the sun. It's basically the same distance all the time because it is an ellipse, but it's not an exaggerated one for the earth. It is for some of the farther planets away from the sun, but for us, we're pretty much in a circular orbit, slightly elliptical. But when we're over here versus when we're over here, there is a difference because the earth is spinning on an axis and that axis is tilted, right, as Justin just said. And over here, we may be tilted this way, and if this is north, right, are we getting more direct or less direct sunlight over here? Less direct because we're tilted away. This would be what season for us? Versus over here, we're still tilted, but we're still tilted in this general direction, not towards the sun in general, but just in an actual larger direction in the sky, right, to the left side of the Promethean board, right? We're going to be tilted all the way around in this path, but it's always this way, and it doesn't matter where the sun is, it's still just always that way. Right, so if it's winter over here, what season do we have over here? Because we're tilted towards, so we get more direct sunlight, because the way it would work. Whereas here and here, this is obviously fall if we're going, I don't even know what I was doing there. This is fall, this is spring. Started into that S a little early. Right? And here, we're not tilted towards, we're not tilted away. Right? At those equinoxes that you guys know of, you've heard of those, right? We have equal amounts of light and night because we're not tilted towards or away. When we're tilted towards the sun, we actually get to see the sun a little bit longer too. The day's a little bit longer. When we're tilted away, the day's a little bit shorter as well, which causes it to be even colder, let alone, just from that direct or indirect path of that sunlight to the surface anyway. So we have those seasons for a reason. This doesn't really affect the tropics so much because, they also get tilted towards and away from the sun. So it might be a little bit warmer up here in our summertime and a little warmer down here in our wintertime, but not noticeably because it's pretty hot all the time, right? So it doesn't really make a whole lot of difference in the tropical regions, but in the temperate zones it does. The other thing you should think about then too, when we have winter, that's not necessarily what's going on for Australia, because Australia is actually tilted towards the sun at that time. So we have flip seasons from them, same with South America. And so if you happen to really like summer weather, you don't have to just migrate to like Arizona. You can go all the way to the southern hemisphere. Be summer all the time. Or you can just live in the tropics and be summer all the time too. But those are just basic things. You don't have any questions on that, right? Good? Alright, so I think that's all we really need to do today. It's just that one little bit. As long as we know why there's those different regions, polar, temperate, tropical, and we know why we have seasons, it's the tilt of the earth, not the curvature then.